Hi all, I'm back with 2011 number 5 AP Calculus AB pre-response question. This is a tricky question. It's tricky for a really nice reason. We get very accustomed to seeing dy dx, dy dx, dy dx, and then in 2011 the AP examiners threw a dw dt in there, the rate of change of w with respect to time, and it really threw people for a loop. They've asked a question similar to this a number of times since 2017, the potato problem. 15 was the baby bird problem. They've asked these things a few different ways. So this thing, at the beginning of 2010, a landfill contains 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. So at time 0, W is equal to 1,400. That's a point on our graph. 0, 1,400 is a point on the graph. Planners estimate that W will satisfy the differential equation dw dt equals 1 over 25 times W minus 300 for the next 20 years. What is this saying? It's important you understand what this is saying. This dw dt is the rate of change of W with respect to time. So how W is changing with respect to time is equal to the amount of waste that you have. So the amount of waste, how it is changing, will differ according to how much waste there actually is. W is measured in tons, and T is measured in years from the start of 2010. Okay, letter A is worth 2 points on their rubric. Let's get it. The line tangent to the graph of W at t equals 0 to approximate the amount of solid waste. Line tangent. Tangent line, I need two things. I need slope and I need point. We're doing the line tangent at t equals 0. So good golly, look it. 0, 1,400 is our point that we already have. That is when t is equal to a 0. So how do I get my slope? Well, dw dt is my slope equation. It is the rate of change of W with respect to time. And it's telling me to figure that out, to figure out that slope equation when t is equal to 0. So I'm going to write that right in here. I'm finding dw dt when t is equal to 0. Well, when t is equal to 0, what does W equal? W just equals 1,400. Now I can get this. This is 1/25th of 1100. Yes, you would be expected to do that without a calculator. The answer there is 44. That's my slope. I have a point. So my line is y is equal to 1,400 times t. Excuse me, I'm so sorry. My line is equal to, let me write it the way we've been writing it. Y minus 1,400 equals 44 times, we can do it with a t minus 0. All right, there is my equation. That's my guesstimate equation. And instead of using y, I could certainly use a w in there if I so desired. I could use a w in order, instead of my y, I could certainly use a w to do that. All right, so what are we going to do now? Well, now we have to figure out at t is equal to 1/4. The first 3 months, so 3 months is 1/4 of a year. We can figure out the amount of waste that there is when t is equal to 1/3. And this is our estimate. All right, 44 times, excuse me, not 1/3, 1/4, I apologize. And this is 1,411 tons. All right, so that's part A. You would have gotten 1 point for solving for the the dw dt, and then a second point for the answer. For letter B, what we're going to do for letter B is find the second derivative in terms of W. So what we have dw dt, let me rewrite it because it's off my screen. There it is. And I'm going to find the second derivative. So I'm literally taking the derivative of this function again with respect to t. Now, if it's easier for you, you can think about this as 1 over 25w minus 12. And that might be nice for some of you. The second derivative here, I have to take the derivative of this thing, this function right here. I have to take the derivative of this. And I'm taking it with respect to time. And it's written in terms of w. So from somewhere in your memory bank, you should realize if you are taking the derivative in terms of t, and you have the equation in terms of w, we need to use a little implicit differentiation. So the second derivative is 1/25 of dw dt. Well, what is dw dt? dw dt is this equation up at the top. dw dt is that equation up there. So this second derivative is 1 over 25 times 1 over 25 times w minus 300. So this is 1 over 625 times w minus 300. That's a point. Now it asks, is this an underestimate or an overestimate? Well, let's think about this. Our w, we are told our w starts at 1400 and it's always getting bigger and bigger and bigger. What does that mean about the second derivative? That means that the second derivative is always going to be greater than 0. My second derivative is bigger than 0 because my w is always bigger than or equal to 1400. So if I plug any w into this second derivative equation, if I plug anything in there, I'm going to get a positive value. That is telling me about the concavity of the curve. This thing is concave up, and therefore, using the tangent line as an estimator, I'm going to get an underestimate. It's an underestimate. It would be underneath. The tangent line would be underneath the curve. It would be an underestimate. Now, part C. Part C is 5 big points. Let's hope we get one this year. It tells me find the particular solution, w equals w of t to the differential equation. If you see, find the particular solution. Separate and integrate. We are going to get everything that includes a w onto one side. We're going to put everything with a t on the other side. This might look a little bit different because it is written in terms of w and t, but this is the same exact principle as when we had x's and y's. I brought everything with a w onto one side and everything with a t on the other side. That's my separate. Once I separate, then I shall integrate. Once I separate, then I integrate. And when I integrate this thing, I get the natural log of w minus 300. I should throw the absolute value bars in there. It's just good practice. I don't really need them in this case because my w is always bigger than 1400, but I'm going to throw them in there anyway. And it tells me my initial condition, the same condition I used back in part A, that 0, 1400. That's how I'm going to get my value for my C. And here it ends up that my C is equal to the natural log of 1100. So what do I have? I have that the natural log of w minus 300, w minus 300. And I'm not going to worry about the absolute value bars because that's always going to be positive. Remember, my w is always going to be bigger than 300 is equal to 1 over 25t plus the natural log of 1100. I'm going to do e to both sides. Now I have W minus 300 equals 1100 e to the 1 over 25t. And finally, this thing I can solve for my W. Here's my particular solution. My particular solution is, I'm going to write it as a decimal just because it just looks better, but it doesn't really matter if you did that. There's my particular solution solving for W. Just to run through quickly where those points come from, 1 point for the separation of the variables, 1 point for taking the antiderivative, 1 point for putting on a constant, remembering the plus c, 1 point for trying to use the initial condition, and then 1 final point for solving for W. And that's something that you should be able to do.